Hey everybody, happy Friday. Hopefully you've had a good work week and are excited about wrapping up your week with us today. So I'm very happy to welcome you to our CUGC user share with Lee Jeffries. You can see he is, I was teasing, I thought he was in an antique shop, but me being in the US with different TV shows, evidently he's not in an antique shop. He is his backdrop is a very famous pub that if I watched a particular show, I would know. But I digress. Before we jump into everything, I just have a couple of announcements for you. We do have our CUGC to go virtual events still happening. Our next one is next week. It's the Swiss group, and it does say French speaking, but I believe some of the sessions will also be in English, so don't let that throw you. Next week, we also have our Connect webinar with Synology talking about high availability storage and disaster recovery. So they're a new sponsor for us. So this will be a new presentation on the CGC webinar stage. So we'll be glad to welcome them. But be sure to check out our calendar for the next events. I know we're adding lots of local group events coming up here through the end of the year. And our next Excel event is Southwest Excel. That's on November 18th. Lots of great content coming at you that day as well. So check out our calendar. Just a reminder that if you have missed some of our webinars or you want to go back in time, we have our full library back to 2015 available on our website. So once you log in to mycugc.org, just click on the Files tab at the top nav bar and hit Webinar Recordings, and there you go. Alrighty, so we are recording today's webinar. So if you want to revisit anything that you see today, you will get a link to the recording afterwards. That email is going to come from GoToWebinar, and it'll either come tomorrow or Monday, depending on how fast I can get the webinar recording ready for you. Also, we want to invite you to submit your questions at any time during the presentation. We'll take them during and after, so just submit them as you have them. And finally, I want you to know I'm going to put in the chat window for you a link to a survey at the end. We like to get your feedback. And this time I've added a new question to the survey. We're planning all of our content for 2021. So if you have ideas for user shares like this one that you would like to see from the community next year, there'll be a question on the survey for you to put your feedback there. All right, so also with us today, I know you can see myself and Lee, is Jake Walsh. Jake is a CTA, and Jake, I think you're in the running probably for maybe moderating. I'll have to tally it up. You may have moderated the most webinars this year. I'm not quite sure. But
Oh, yes,
Jake
pleasure
is...
to be here. Yeah, thank you.
Jake's going to keep an eye on the questions for you, for us today, and he's going to ask them, as they come up. So I know you've already heard his voice, but Jake, you want to say hello?
Yeah, hi everyone. Thanks, Stephanie. So yeah, pleasure to be here. Obviously, my name is Jake Walsh. I'm a consultant working in the UK. I had the pleasure of seeing quite a lot of Lee's content actually, both in person and virtually. So I know we've got an awesome presentation here today. Please do keep firing your questions in. I'll do my best to answer some, and we'll ask some to Lee as well. And then I'll hand over to Lee.
Thanks, Jake. And of course, we have Lee Jeffries. He is a CTP and an IT consultant. And Lee, I'm going to give everything over to you now. I'm going to get off of my camera, and I'm going to give you the screen and let you take it away.
Cool. Thanks, Stephanie. Cheers, Jake. I've got to get a different picture. I keep cancelling these synergy events. I definitely need a new profile picture. That one's is of a much younger me, when I probably still could grow hair actually. Okay.
I'm just thinking before we get started, any attendees want a pint whilst Lee's in the pub? Get your orders in.
Yeah. I think if I sit back, if I put my arm up here, I can sort of look like I'm propped. Cool. All right, but today's not about the pub quite yet. We're almost there. Not very many minutes left. So today's about PowerScale. For anyone that doesn't know what PowerScale is, it is a script that I put together when SmartScale was originally deprecated, and I've been working on it ever since. So it's still being maintained in GitHub. Jake, you can see my slides, right?
I can indeed, yeah.
Cool. All right. So the agenda today, I want to give a bit of an introduction on public cloud scenarios, scaling up machines, and general logon processes, as well as some of the challenges that come with that. How PowerScale is going to help with those situations. We'll run over the installation of the solution and how you pull it together with some very basic configuration, and then we'll run through some of the configuration reference. Now, PowerScale also generates a static HTML dashboard for you based on what it's doing, so you can always go back and have a look at what's happening. So we will run over those points, and as Jake said earlier, and if you've got questions as we go along, please stop me. There's a lot of content, and I will be hammering through this probably at a few 100 miles an hour. But let's crack on. Okay, so this is a graph of an environment, and it's a typical graph of an example, or an example of a week in a remote desktop environment. So each day represents users logging into an environment and then logging out again. Right, so very atypical. And when we look at a graph like that, we have users up one side, and we have time down the bottom, and we just have a single day represented something along these lines, right? So the explanations and the graphs I'm going to be talking about, they all relate to this sort of format. Must point out these slides are courtesy of Mr. Moyle. Thanks, Jim. I appreciate you lending me these because it helped me explain the scenario. So here we have a 600 user environment where all users are logged in and working within a period of around 60 minutes. Okay, so you can see by the graph, we've got a logon rate there spread over that 60 minutes, and we've got quite a steep incline on that graph. So it's not a perfect example of a daily scenario. As we said, that graph right at the beginning is a bit more bumpy and humpy, but this is ideal. So everybody comes in at 8, they're all logged on by 9 o'clock, they work all day flat out, and then they all leave at 5 o'clock. So what about 1100 users? So we're now in a position where we've got to get 1100 users there. So if we increase to 1100 users, we've got a much steeper incline now. All right, so again, that's the same numbers, different numbers, but over a period of 60 minutes. So we need to work out how we manage this, right? Because we've got to get all these machines turned on. And we obviously need to provision these machines for the users. And as we all know, we have a time frame for these machines to be ready for these users to log into. So specifically talking about public cloud scenarios, we've got a bit of a dilemma here. Do we power on existing machines, persistent VMs, or do we spin up non-persistent VMs, which is sort of a create and shut down destroy methodology? So we need to think about what we're doing with these machines. So we've obviously got a lag time to either one of those, and then a maintenance factor to consider as well. So we're back to balancing user experience, cost and management in this sort of scenario. So let's dig into this. For 1,000 users to be able to log in the period of time required, we actually need to provision machines earlier than are required. And then in order to cope with the login window, we need to add a little bit of a buffer, right? So in this example, we actually need enough machines for 1,200 users in order to provide the logon rate for the users to all log in within that given time frame. So if we look at the graph, what we actually need is something like this. Right, so we've got our 1,000 users that need to log in, but actually in order to be able to cope with that sort of deployment time frame and the logon rate, we actually need to provision more machines and make them available. So it's actually a 20% buffer here, right? We actually need these machines switched on and available before these users start logging in to be able to compensate for that log on rate. Now that's not good for businesses that are running workloads in public cloud, because what it actually equates to is that we have 35% of those machines empty. So we're actually paying for those 35% of that infrastructure anyway, and they're not really doing anything. We just need them there. So our problem here is almost the same. We've still got a 20% buffer, but now we want 30 sessions a second. So now we need more machines switched on, right? So we've got deployment time to consider, and we need to start up these machines again before the users start logging in. And what that actually equates to is 49% of our machines effectively being empty. What happens if we scale that up even further? Large enterprise. Okay, 10,000 users. But now we need 12,000 machines. And this is with the original 150 sessions a second. So more machines, accounting again for the deployment lag and the log on rate. What does it look like? Ouch. Okay, so now we're at 57% of our machines being empty. So that's going to be a tough sell, especially if your costs are already pretty high. Okay, so that's just painting a picture for that sort of scenario and what you've got to consider when you are actually spinning up these environments in public cloud environments. And PowerScale is going to not necessarily fix this issue for you, but it's going to allow you to scale in a bit more of a gradual way, perhaps depending on your scenario, scale on performance or something along those lines. So I'll relate back to this. A survey slide from VDI Like a Pro, and this is all about concurrent usage in server-based compute environments. Okay, what sort of size environments we're looking at. So I mean the largest one there, or the largest percentage, is 1,000 to 5,000 users. So you're talking about a lot of people really potentially having a problem with costing and this sort of ramp up. Something else to consider: cloud API limits. So don't forget these in cloud environments. Every cloud provider has them. And if you're planning to spin up many machines all at once, you'll need to make sure you are able to respect these limits. There are always ways to handle the limitations. You can request an increase in your API limits, split subscriptions, specifically with my experience relating to Azure. Bear in mind, PowerScale, AutoScale, third-party providers, they all use APIs, and all APIs have rate limits. So make sure that's on your question list for any supplier that you're working with. If you want to find out what your limit is for Azure, you can run this command in the CLI and it will respond to you with where you sit right now. Okay. So what do we do about this? A big multi-session VMs better, or lots of smaller ones better? And that's more of a larger question, really. How do we know? They might not necessarily be as efficient without a predictable user pattern. You're going to know your business, so you'll know what your what your users' behavior is like. So larger machines can be more efficient because obviously you have less to shut down, but obviously they're more difficult to clear off as well. So you've got to sort of be able to simulate these scenarios. What about load balancing methods as well, or scaling? So Citrix in particular, as I say, that's where most of my skill set is. So they have an option for you to be able to use vertical load balancing, right? So horizontal means load balancing will spread all of the users across multiple VMs. doesn't matter what size they are. Vertical is actually an option you can flag for a site, and instead of load balancing those users across multiple VMs, what it will do is it will fill one up at a time, and it will only start using the next one when each one is at capacity. And you configure that capacity too. So that's another thing to consider and to weigh up when you're trying to make these decisions. So lucky me, I've got a simulation script. So what happens when users go home? So the red box, green box is a server, and the blue boxes are users, right? And the blue boxes, they disappear as users log out, right? So once all the users are gone, the box is empty, it can be shut down. But users don't log out like that. Users log out like this. All very random. And when you've got multiple servers, it might look something like this. So 512 users. All these users are logging off of these machines, again, randomly. And the idea of this simulation is to look at how many machines we need to shut down. How many users need to log off in order for us to shut down 50% of our servers in order to get that cost saving. So that's 25% of the user estate gone. We continue to let these guys log off. It's obviously not Friday, okay, because they're genuinely taking a bit of time. %50 gone. We still haven't shut down any servers though. Okay, so we're not saving any money right now. So we carry on, we let them keep going at it. We're nearly there. %75% of users logged off. Still no servers shut down. Pretty high, right? So we keep going. One server's gone. So 78% of all of users had to log out in order for us to shut down one server. So we keep going a bit faster now. And as you can see, these users logging out, we're shutting down servers, and we're eventually going to get to a point where we reach a percentage of users that needed to log off, go home, in order for us to shut down just 50%. Okay, so 21 users left, or 4% of the population, and that's half the servers shut down. So that's it. We finish up with the rest of them, but as you can see, quite a lot of users have got to log off before you can actually start shutting down those instances, hence costing you a bit of money. Okay, so we're going to do this a couple more times, a bit faster. And it's random, right? It's completely random how these users are logging off. It's all been scripted and run multiple times. Okay, see what number we get to this time. Okay, 19 users left, still 4% of the population. Okay, it seems like there's a pattern occurring. Okay, so 96% of all users have to be unchained from their desk and allowed to run away very excitedly in order for you to be able to shut down 50% of your machines. Okay, right. So what happens if you've got different numbers? So this is a first run based on the number of users, number of users per server. And this is a second run. Okay, so this wasn't just run once or twice, this was run multiple times. And you can see actually you need a large percent of your user estate to log off of your servers in order for you to be able to shut them down. Now, I'm very lucky and I was given this clever equation that directly relates to this, which is the probability a server is empty equals the probability of a single user being logged off to the power of users per server, which makes perfect sense. But it was a more intelligent person than me that came up with that. So again, Jim, thanks for the slides, much appreciated. So moving on to the PowerScale piece. Right, so we've painted a picture where we've got these machines being powered up, and we need a certain amount powered on in the morning before the users are able to log in. And then we've got a deployment time for additional machines as well. We need to be able to scale that pretty gradually, and we need a tool to be able to do that. And there are other tools, but this particular one is one that I've put together and maintained. So how can PowerScale help? Well, it performs startup and shutdown of machines, and it gives you a number of options for you to be able to do that. You can power up a big bunch, or you can power up a small buffer and allow the rest to scale. It can scale these machines up based on CPU, memory, load index, or sessions, number of sessions. Now, these values are across the board, right? It's not just one machine that it monitors all the machines, and then it creates you a big average. And it's that average that it provides the scaling metrics on. So the dashboard that you're gonna be able to view with this, it covers machines that turned on, maintenance mode, scaled machines, as well as all those performance metrics I talked about. And we can historically configure retention for that, as well as gracefully allowing users to log off, including respecting disconnected sessions if you wish, or forcefully logging these users off by sending them messages in given intervals. So I want to talk a little bit about the installation. Me and Jake gave a webinar a while ago, probably over a year ago, about installing PowerScale and getting it running. So I want to blitz over these slides quite quickly. It's not very complicated. It really is a three-step process. Download it, configure it, and test it. So the way PowerScale works, it's using the Citrix broker and the PowerShell SDK. So it does not matter where your workloads are running as long as they're going through a broker. Now, someone asked me the other day, could this run on Citrix Cloud? Right now it doesn't. I tried it, but it's purely because I need a different SDK installed. I think it probably will work, but I have a think about that, and that'll be coming. So customize it to your needs. There is a wiki which goes through all of the steps in order to be able to get this set up. So my lab, just for this usage, I've got one DC, one delivery controller, and six VMs, which are MCS VMs. A production environment would obviously be bigger, but just for me to tweak these things and work out what's going on, develop the script, that's what I use. So it's not huge, but I have got people that have downloaded this and are using this with thousands of machines running in cloud environments, which is fantastic to hear, right? There's nothing better than to know that something you've built is being used on large enterprise scale. So to run PowerScale, the following prereqs are required. You need the Citrix PowerShell SDK, or you can just install Studio. It goes on with that. You need Windows Remote Management enabled for performance capture and everything else. And it's optional, but a service account. So some people don't want to run the script with a service account, but they do want the performance capture will need to be done with a service account. So that's an option in there as well. My account is a Citrix admin and a local admin on a session host, so I don't need to use the service account. I have in the example, but I don't need to. So dead simple, grab it from GitHub, put it in a folder, and you should see something along these lines. Right, so the template folder is the only one you can't really get rid of, and the 2 PowerShell files. Everything else is optional. So next we need to configure it. And to configure it, we just open up that create config script. And that create config script, although it looks like a config file, it's actually a PowerShell script that generates the XML file that's read. So you need to fill in some details in here to get it to work for you. So for a very quick start, all you need to fill in are these as a very bare minimum. Right, and as I said earlier, the authentication service stuff, that's optional if your account is an admin in the right areas anyway. So we need our controller address. We need a way of picking up the machines and selecting the machines we want to manage. In this particular example, I'm using a prefix, which is just a naming convention for your hosts. But it also supports delivery group, machine catalog, and the use of tags. Put in your start time and your end time of your business, how many machines you want out of hours and how many you want in hours. The last bit, probably the most important bit, there is a testing only flag. Put that on true. Don't run this on a live environment without really letting it do its thing first. What that flag does is ensure that any particular power actions that would be performed do not happen. It will still gather performance metrics, but it will not shut down any machines. What you will get, however, is an evaluation of this is your environment right now, this is what I would have done. And if you run that, say, for a period of 24 hours, it will spit you out a nice log file you can look at, and it will tell you every time it runs what it would have done with your environment at that particular point in time. So you can actually slide this in against any other power management solution and sort of get an audit trail of what it would have done. So once you've done all that, run the config script and it will create the XML file for you. It also takes the password that you supply for your service account if you've put it in, and it encrypts it in a key file. So someone can't come along and just pick those out for you. So a very brief video on how this hangs together. Okay, so as I said, we run off to GitHub and we grab PowerScale. This is a Windows 10 machine, but it doesn't matter as long as you run it on Windows and it's got the prereqs, doesn't matter. In this video, I'm going through setting it up and then configuring it. So the way to get this to run on a regular basis is really to set it up as a scheduled task. I don't cover that in the video, but I have covered it on the wiki. So in the folder, straight away we go for our create config file. So the very first option is just a title basically for your dashboard. And you can call that whatever you like. The next step down, okay, we need to tell it where our machines are. And you can see there it's set to prefix. Sorry, my mistake. I'm putting in my Citrix controller here. So you just need a name. And then I'm setting my prefix for my session servers. So it will run a query against the delivery controller and pick out anything with that naming convention. Set my business start time. I want between 8 and 6. And then optionally set your business days. Put in how many machines you want out of hours, how many you want in. So I want 1 and 4. And then you can set up your machine scaling and tell it how you want to scale. In this example, it's session-based scaling. And I've said I want six users on each server before you spin me up another one. Our script run interval is set to 15 minutes. It could be sooner. Just bear in mind if you do that, you need to make sure that your machines will fire up before the next script run. I'll populate some details. So I've left it in testing mode and I've put in my service account credentials. Next, I'm just changing the execution policy so that this will run unhindered. And you'll see here, when I click play, it runs through that, packages it all up in an XML file. So going into the PowerScale folder, I've got 2 key files and a config file. So I'll have a look in the config file just to show you what it looks like. This is actually a PowerShell object that's exported as an XML file. You can edit it directly if you want to, but you can see there all the details that I've put in, they're all listed. Cool, so all I have to do now is open up my decision-making script or set it up as a scheduled task to run, and then again hit play. It reads my XML file that I've just configured, and it's run off and it's grabbing performance information from a server. So if I go back here, you can see now I have a dashboard folder. And if I open up my dashboard HTML, you can see I've got a sort of graph. Not a lot there right now because we've only run it once, so I've only got one data point. So I've run it again in this example. Now what you'll see here is I'm highlighting in this video, it actually chose to fire up 3 machines on that second run. Okay, so it's picked up, I asked for 4 machines during working hours. That would have given me my 4 machines. Cool. Any questions you want to interrupt me with so far, Jake?
No, nothing at the moment. All looking good. Had a couple come in that I've been answering, but I've got a few saved up just towards the end. But yeah, all looking good so far.
No problem. All right. So I actually have a configuration reference for this. So it's pretty sparse, and as techie people, we don't love spending lots of time doing documentation, but we do love spending lots of time writing scripts. So this is really huge, actually. It's something, I don't know, it's like 1,400 lines or something. Citrix farm settings. So I mentioned, machine detection and your prefix or your delivery groups, catalogs, tags. It will take multiple delivery groups and loop through both of those and power manage them. And machine scaling, there's lots of options here. Now, in particular, what I wanted to look at was there is an option to scale outside of hours or not scale outside of hours. So actually, if you've only got one machine turned on to just service users outside of hours, you can have that still scale up additional ones for you. Also, we have something called additional scaling. So I want to revert right back to that graph that we talked about at the beginning, where we sort of got that ramp up time and that deployment window that we need to cater for. This additional scaling variable, what this does is allow you to specify a time where rather than spinning up just one machine every single time it detects it into a new one, you can tell it to spin up more than one machine just in that window of time. So for example, if you needed that to scale much quicker, as long as you configured all your sort of session, your load index correctly and stuff like that, you could end up spinning up all of your estate over a gradual period, but with enough to support your users. So that was what that was in there for. And someone actually requested that for that exact scenario. Also, what PowerScale will do is if you tell it you only want one machine available outside of business hours, as soon as it gets outside of business hours, it will look at all of your machines, look at disconnected sessions, get rid of all those, and then any machines that it manages to clear, it will shut down. But it will shut them down all at once. And it includes machines during the day that it's scaled up. If those machines then become empty, it will try and scale those down too. Now, what we were finding in larger environments was these machines were being spun up and users weren't actually straight away going onto them, and PowerScale was killing them all. So what you ended up with a graph is like a big drop off the graph straight away. So there is an option there to do restrictive scaling down, where you can limit the amount of machines it shuts down, and it will just shut down that number of machines on each run until it gets to the target it requires. But basically, have a look through this. If you're wondering what is in that config file and what the things do, have a flick through this, and it basically breaks it all down for you. Okay, so.
Can I just jump in with one quick question, Lee, if that's okay? Just one around the script interval. So is that run automatically, or is that something that has to be configured? So there's a question here. So if you've got the script configured and you want it to run on an interval, is that the interval you would configure on your scheduled task?
Yes, spot on.
Yeah, no, that's
so
brilliant.
Yeah, spin up a scheduled task, set the interval the same as you set it in the config file. Basically, the way the dashboard and the log retention works, you set a time in the config for when you want that to happen. The reason that's there for is obviously if you've got a dashboard, you will want that to switch over and start recording another day at a certain time. So the reason the script interval is important is it actually uses leeway either side of that time that you set to say, now I need to do my retention job.
Yeah, Brilliant, thank you.
No problem. So talking a bit about behavior, we do power on machines with PowerScale, but by default, if you have machines in maintenance mode, it will take them out of maintenance mode first. So for anyone that decides to put this in and they get annoyed because they put a machine in maintenance mode and it keeps coming out, it's this. So if you want to exclude a machine from calculations to work on it, or just not have a user even affected by this, you can configure a tag in the config file, and PowerScale will ignore those machines with those tags. If you're not sure what tags are in Studio, let me know. Powering down machines, we can choose to wait 4 sessions to drain, and there is an optional parameter to respect disconnected sessions or not, or you can message the users and kick them off if you want to put the hammer down. Depends how much you want to save costs and what the nature of your business is. We have a single configuration XML. So it doesn't look anywhere for anything else. There's no database. It doesn't grab anything online to do anything. You can edit the config manually, and there are comments in the config. So if you look in the config, you'll see your option, and just below it, you'll see an entry for a comment. The reason that's there is just to make it easier if you do make inline edits. So I mentioned test mode. It's really important. I always recommend that people use that. Stops you making any mistakes. And then you can turn performance scaling on or off. You don't have to have PowerScale doing performance scaling. This could be used just as I want to start something up in the morning or shut it down in the evening. And that's pretty much how it started. So performance scaling options though, I mentioned earlier we can do it on session. So session numbers, load index, CPU or memory. Right, and I will jump into some dashboards and stop talking through lots of textual slides in a little while. So the way this works, it takes the CPU and the memory and everything from all of these machines that you have available, and then it averages that out, and that's what you see on your graph eventually. So it makes its decisions based on an average of the farm. So just bear that in mind when you're trying to configure that. Personally, the best way of doing this I've found is to use the load index, because then you can configure your balance between CPU and memory or sessions on a box, and then you can use that as an average in order to be able to make those scaling calculations. And it actually gives you seriously granular decision making on how things need to be spun up. To collect performance metrics, I use sim sessions, right, which is pretty widely used and pretty open. You can actually pick how many performance samples you want to take and what your interval is between samples. So by default, it checks 5 times for CPU, for memory usage every second. So 5 seconds of samples. This bit of the script originally was very slow. I was using PowerShell jobs, and quite frankly, they're awful. They're very slow and they eat loads of CPU. It's actually using run spaces right now, so you can configure the maximum number of threads and it will spin through all of those machines quite quickly. Just make sure you're not allocating too many threads, because you will see problems. So what you want to do is go for well, it varies, I suppose, but I've seen success double allocating the amount of threads that you have. So if you've got 8 CPUs, you can put 16 in there. It's usually okay. So session log-offs, do you force or not force? And these are the options that allow you to decide if you're forcing log-offs or you're not. If you set force log-off to false, it will gracefully just wait for users to disconnect, and when those machines are empty, it will shut them down. If you set it to true, you are able to configure 2 messages with a log-off interval for each. So the interval will be, you send them a message, it waits for a period of time, it sends them another message, it waits for a period of time, and then it shuts those boxes down. As I mentioned earlier, we exclude machines by using tags in Studio. So the default in the config is just excluded. So just create a tag for that, pop that in your pop that in Studio, and it will just ignore those machines like they don't exist. I mentioned this earlier about the service account password being encrypted. It's a question I get a lot about putting, passwords in plain text. Just remember not to leave it in your config file. When you run it, PowerShell saves it before it runs it. Just remember to take it out and save it before you proceed. And lastly, logging. This script generates a lot of information when it runs because obviously you want to know what it's doing in your environment. So there's a log, and that log will have a date timestamp on it every time it's retained. Is the one I want to say. Is the word I want to say. So you pick how many log files you want to keep, and you can also pick the location if you like. And lastly, I think that's the last slide of text. Yep. Dashboard files. So these, as I mentioned, these are static HTML dashboard files. You pick how many you want to retain, and you pick the backup time. All right, so that's where I said earlier, the script run interval is really important because it actually uses the time window either side of your backup time to decide that it's going to do a script backup. So what do these dashboards look like? Right, we can hop in the lab and have a bit of a play now. Cool. All right, so we've got some PowerScale machines in the lab. Currently got one turned on. Okay, so the dreaded Windows updates. Okay, so I ran this, and I have a script that I use for testing, and what it does is it simulates these loads. It basically passes a time and a date to the PowerScale script, and then that runs as if it's that time of day and evaluates the script options. However, what it tends to do, because I run it too quickly, is the machines get shut down, spun up, shut down, spun up. So that's why the graphs look a bit wafty, but this is eventually what you will end up with. So I just ran that 200 times, and it generated me almost 3 days. So what you'll end up seeing is when your machines are turned on and turned off, and this is the sort of ramp up, ramp down. And then you'll end up with CPU metrics across as an average. Then you've got your memory, load index, nice fat zeros, and sessions, for some reason, are nice fat zeros here. And the reason for that is I had no sessions on these boxes. But what it does is it maintains this navigation for you, so you don't have to go away and open up another file. And because it's static, you've obviously got a record of what happened on individual days. So where we've gone down to one machine, our CPU usage jumps up as an average across the farm because we've only got one machine available now. Same for memory. We do have a recorded errors section on the right, which picks out specific bits from the log file. So if it finds an error in the log file, you'll see it displayed here. And we've got all the settings that are most relevant from that config file too. So it's going to tell you what your dashboard retention is, what your business hours are, additional scaling and bits and pieces like that. So all this stuff, dead easy to stick on a screen somewhere, and then you can see what's happening with your farm. Okay, excellent. All right, so sample use cases, right? And this was more around what can this do and how does it relate to some scenarios. So for people that are worried about cloud costs, obviously you can use this in order to power up those machines, as I said earlier, to cope for that sort of log on time and ramp up. And then you can use it to power them down at the end of the day. If you're really worried about costs, message your users and kick them off. As I said, this is always up for development, and I'm always maintaining it. So if people have got good ideas here, someone did ask me about cloud cost calculator, like working out how much money you'd be saving. I haven't quite worked out how I'd implement that yet, but it's interesting. So for that one, use the tool to spin up, spin down the machines, and if you want to, if cost is a priority, boot those users off. What about in on-prem environments? Because cloud is good, and I know cloud is the way of the future, but a lot of organizations are still running on-prem right now, especially at the moment. Infrastructure is really heavily utilized. Most of that is EUC stuff. So where you've got infrastructure doing batch processing overnight, you may actually want to consider powering down some of those machines and automatically maybe beefing up your batch processing machine so you can get through that stuff quicker. And that's the sort of thing that this will do, because it's working through the broker. It's not necessarily reliant on any particular type of technology other than the Citrix piece. Then you have the ability to be able to do things like that. What about an environment where all the machines must be controlled? So where you've got highly secure environments, or maybe training environments even, you could actually use this to control those environments. So as long as that script runtime is relatively regular, if anyone does decide to come in and try and launch desktops, you can actually just power those off. You can even limit it to certain days, so it's only during a controlled period. So there's a few different options here. Cool. All right, so I left this slide here, regular run examples, right, in the hope that someone would have some ideas about maybe what about a particular type of configuration that you'd want to run. Has anybody got any suggestions, or has anything been put on the questions?
We do have one question here actually, was around ensuring that a single machine doesn't stay up for more than a week. Now I'm not sure if that's built into this. It's a little bit left field. But obviously, I guess some people might be thinking machines could be scaling up and down, but if they wanted to make it so, for example, you know, that scaling up and down wasn't always the same machines, or just by chance, is there any way you could facilitate that? I know that's a little bit perhaps on the periphery of what the script does. But also we have another question that's popped in as well around, you know, could you say, for example, that a session could only carry on for a certain amount of time, or, you know, once a user logged in, there was a time limit or something like that? We might have just given you two future features there.
No, they're really good ideas, right? Because actually, I mean, when it's shutting down the machines, that's pretty much completely random, because you're dependent on the users logging off. So making sure, but there would be no reasons why a machine couldn't be prioritized. Say if it's been on for a long period of time, that'd be entirely possible to do. And the way I'd probably do that, just off the top of my head, was I'd stick a tag in Studio to mark that machine as sort of priority, if you like. And then as soon as that one was empty, I'd make sure, or even overnight, make sure that one's gone down. Because it would always keep a certain amount on, right? But you'd also, so it'd be prioritizing that machine over the other ones effectively. And the other one was, Jake, remind me again. It is bright out. I am in the pub.
This is around the limits to the time that a session would be logged on for. So for example, could it target, for example, this server's had people logged in for 10 hours, 12 hours or something like that? I guess this kind of crux of that question might be around, for example, the kind of people that just turn their thin client off and go home, and actually the session is still running or something like that. You know, if you knew that the working day was 9 to 5 for everyone, if you could sort of, I guess that's very, very difficult to determine, because a user logged in doesn't tell you whether that user's still working or not, for example. But if you did have an environment that was very static, everybody on at 9 and everybody off at 5, I guess that time limit might be a potential way to control it.
Yeah, I mean that's entirely possible. There's not a problem with any of that. So I think the way I read that, or the way my thought process was going, was actually like a time constrained login. So this person can use the desktop but only for an hour, or something along those lines. And that also would that would be quite easy to fit something like that into this. So at the moment, it obviously makes a decision based on whether or not the machine is empty. There is no reason why it couldn't make a separate decision to say, well, actually, also, if we find a user that's been on for more than an hour, why don't we send them some messages and log them off and tell them they're to time. So yeah, I think, yep, both of it could be managed. It's not there right now, but as I said, hop on GitHub, put something on there, and we'll connect. We'll get it done. If there's a use case, I'm up for it. So I think what I'll do, because we're well close to the end, but I think what I'll do is I'll just fire up the folder just to sort of have a look at the layout, right? And specifically the log. I talked a lot about the log, and I just wanted to sort of highlight the points in here. So depending on what this script is doing, it's very verbose and it will give you quite a lot of info. So all the bits on the graph that I highlighted earlier on the dashboard, so that's on the 22nd, right, of October. Just to show you sort of in comparison to the graph what this is doing. Okay, so we had request to start up machines here at 11:22. So if I find 11:22 here, we can look at our script runs and we can see at 11:30, if we follow that line up, we've got one machine turned on, we've got another turned on. Now, I said this was like really wavy, this graph, right? But I can actually skip through this log file now, knowing where I am. It's telling me the current number of machines it's powered on is 4, and the target's 4. So the resulting action is to perform scaling calculations to see if it needs to scale up any additional machines. Okay, cool. So it's said scaling has been selected, the current scaling metric CPU, and it's decided it needs to scale up some more machines. And it's saying I'm working with powered off machines because there's none in maintenance mode, and I'm going to fire up another one. So that's the sort of level of logging you're going to get out of this as you step through working with this. Okay. All right. Cool. Well, that's good. That's good. So quotes and thanks. So I always do this, or try and do this in presentations. Thank people that have helped me in the community and contributed to me being able to put this together. So I want to thank Jake, as always. Jake did my first PowerScale webinar, co-presented with me, and he just happened to be my moderator for this one as well, so thank you, Jake. Then Dennis Span, he is the clever man that came up with encrypting passwords in files, and completely copied that. Jim gave me my my inspiration and cloud scaling slides and simulation code. That simulation code is very cool, and Jim gave a presentation. I suggest you pick out, it was, I think, the Virtual Expo. So check that out if you haven't, because he does a much better job than me of running through those slides, and he's got a few more. I streamlined it. And I want to thank Guy Leach for Run Spaces. When I tried to implement that, I think I spent about a day fiddling with that. And he managed to, over Twitter, untangle my brain. So thanks to Guy. If you're interested in running PowerScale, you've got questions or anything really, join the World of EUC Slack channel, and there is a PowerScale channel on there, and there is the link. So any further questions?
We've had quite a few come in actually, if that's okay.
Yeah,
so one of the questions was around the history on the dashboard. Is that retained for a set period of time, or is that configurable in any way?
It is indeed. All right, so I'm going to get rid of the log file for now. Let me fire up this this create config. So I have a different one here for my testing purposes, where I'm doing development stuff and I don't want it to be synced to GitHub. So down here we have a retention option. Here we go. So you have a dashboard retention option. At the moment, I want 5 of these, and I'd like you to rotate them at 4 AM every day. So what you'll see here is in the dashboard, I've actually got 4, right? I've got my current one right now, and then I've got 3 more. And if I'd carried on going, I would have got a 5th. And then what it will do after the 5th is it will just drop the latest or the earliest date and carry on again. So you'll notice here, this one starts from 4:30 because it would have shifted around the dashboard at about 4:15 in the morning. So that would be the original. Here we go. There you go. So they're all starting at 4:30, and they should all finish at 4 o'clock. That makes sense? So yeah, fully configurable.
Yeah, no, that's awesome. Thank you. Just having a read of the other questions. I actually have one as well. So around sort of limitations of hypervisor, are there actually any hypervisor limitations, or is it really a case of the script is just talking to the broker service, and as long as the broker service is talking to a hypervisor of some sort, as long as it's supported in that regard, i.e. power operations, that's really, there's no kind of limitation.
Yep, exactly, spot on. So I'm sure everybody's aware that if you're using anything newer than 1912, you can actually no longer publish workloads into public cloud anyway. It's not supported by Citrix. But I have VMware and Zen Server in the lab, and I can put machines on either of those. The hypervisor doesn't matter a jot. It's literally just using whatever Citrix has already programmed in there to send those power actions to those machines.
One of the other questions as well was around SMTP configuration. Is that something you can configure as well, so you get sort of status emails or updates or anything like that?
At the moment, it's configured. There is SMTP in here, and what it's used for is errors when the script doesn't run. It will ping you an email to let you know that actually that script failed to run, or there was a problem running the script. And it literally pulls the errors out of the log, pretty much the same as the dashboard does. But there would be absolutely no reason why there couldn't be something generated. Those dashboards, then it uses JavaScript, so they are sort of dynamic in a way, and it is reading JSON files, but it wouldn't be difficult to send some sort of dashboard email or some sort of update.
Oh, that's awesome.
It's not in there right now, but it could be.
Just seeing if we've got any other questions. I think that's about it on the question front. Looks like we've covered most of them.
Okay, cool. In that case, I think I'll thank everyone for spending their Friday afternoon with me at the end of the day. And again, pleasure. Cheers, Jake.
All right.
Thanks,
I
Steve.
have a trivia question. Let me get my screen ready. So the first 3 people, excuse me, sorry about that. The first 3 people to answer the question correctly will win a 2020 CUGC t-shirt. And I'm just getting ready. Okay, there we go. So how does PowerScale collect performance metrics? I see 1. 2. 3.
That was quick.
That was quick. I wasn't. All right. So congratulations. Huh?
That was some lightning fast responses.
Congratulations, Steve and Jim and David. I will get in touch with you after the webinar and get your size and info and all that, and we'll get those shirts out to you. All right. All right. Well, thank you so much for being with us today. Really appreciate everybody. I guess I'll turn my camera back on so Lee's not all by himself. Hi, Lee.
Don't mind, Stephanie, it's fine.
Appreciate all of you guys being with us today, and hope that you all enjoy the rest of your weekend. It's finally here, right? Almost for me. It's midday for me, so I still have, I mean, you can see it's light outside behind me. But I hope you all enjoy the rest of your weekend. And thank you again, Lee. Thanks for doing this. And thank you, Jake, for being on with us today.
No worries. Have a good weekend, guys. Cheers.
All
Thanks,
right,
everyone.
bye, everybody.